morning, everyone, and welcome to this Pro Vice Chancellor hosted series. And as a school, it's a big privilege for me to welcome each of you to listen to a very eminent ecological economist, if I may frame you in that sense. Um, The topic that we will be hearing more about today, I don't need to emphasize, is highly relevant, and especially in a context where we are constantly used to tracking GDP as the scorecard of progress, what our markets respond to, and policymakers take as measure of their own success. Really speaking, does not tell the whole truth. We are aware GDP often does not capture the most valuable contributions that depend on not just the ecosystem, but also at a household level, unpaid care work and labor. So GDP obviously is not a perfect measure. What we will be listening to today would be how a more refined, progressive measure can be developed that incorporates the contributions of the ecosystem, not just as a source of income, but the cost of growth and development as visible through depletion of nature. So it's important to incorporate not just the contribution, but the cost, because the cost oftentimes is borne not by this generation, but by future generations. So a lot of these would be very important for the young audience who have their future ahead of them. And of course, it would be pertinent, especially in the context of the just energy transitions that we constantly deal with in this country. So with that backdrop, let me introduce Professor Stephen Polasky formally to the audience before handing over the podium for the presentation. Dr. Stephen Polasky is a Regents Professor and the Fessler-Lampert Professor of Ecological and Environmental Economics at the University of Minnesota, renowned for his pioneering interdisciplinary research at the intersection of ecology and economics. His work fundamentally focuses on quantifying the contribution of nature to human well-being by developing methodologies to value ecosystem services and natural capital, thereby making these values visible and relevant for public as well as private decision-making. As a co-founder of the Natural Capital Project, he has been instrumental in creating tools like the INVEST software, which allows governments and organizations worldwide to map and model the impacts of land use decisions. His research extends to exploring sustainability, biodiversity conservation, and the design of environmental policies, aiming to integrate natural capital accounting into national economic indicators like GDP to foster more sustainable development. Elected to the US National Academy of Sciences in 2010 and a fellow of several other prestigious academies, his work has profoundly influenced both academic thought and practical policy frameworks for environmental management and conservation. With that, let me welcome Prof. to make his presentation.
Thank you. Thank you for the very kind introduction. Thank you all for being here. People ask, is this your first trip to South Africa? And I say, actually, no, I've been here a number of times, but I do remember very well my first trip through Johannesburg Airport a number of years ago. It was during our summer, but your winter. And I brought the first snow to Johannesburg Airport in 26 years. And so we were supposed to take off at 6 or 7 a.m., get out there, and of course, there's ice on the wings and we can't take off. And because there's not snow in Johannesburg very often, you don't have de-icing equipment. And so we had to wait till the sun come up and melt off all the ice. Anyway, we did make it out. It's wonderful to be here. So today I want to talk about something called gross ecosystem product, or GEP. And as you heard in the introduction about GDP, which is a statistic that's probably the most widely reported and used statistic in the world. So this is a deliberately trying to take or parallel GDP, but to bring in the value of nature. So E stands for ecosystem here. So ecosystem product, ecosystem goods and services. And then I'll also talk about this notion of inclusive wealth. So GEP, just like GDP, is a measure of current income. That doesn't tell you anything about sustainability over the long term. So as you mentioned, we can do things which would deplete natural capital, which means people in the future are not going to be as well off unless we do replace it with some other kind of capital, and whether that's possible or not. So inclusive wealth is a measure that talks about, are we leaving for next generations, are we leaving them with capabilities that exceed our own? Are they going to be able to be as well off or better? You can't do this kind of work, which is very interdisciplinary, as you'll see in a moment, without a lot of help. So this is actually on a forthcoming a work in progress on GEP. All of my co-authors, many of them at University of Minnesota, but also at Stanford University, at Stockholm Resilience Center, at the Chinese Academy of Sciences, and a number of other institutions around the world. Getting back to this notion of GDP and going beyond GDP, GDP is very useful for certain things, right? There's some people who say we should get rid of GDP. No, it's very useful for understanding what's going on in the economy. Is the economy, as classically measured goods and services, is income going up or falling? And it's easily understood and obviously very widely used. But as already indicated, it doesn't do everything that we wish, right? This is not a measure of welfare. It's not a measure of progress of society. And it leaves out many important things which you would want as a measure of progress for society. Now, I'm going to talk I'm not fixing all of GDP's problems. You can do the other half, or the other 2/3. But I am going to talk about how do we bring the contributions of nature into this kind of accounting and bring it into, therefore, this kind of public and private decision making that does rely on economic statistics. That there currently is no widely available summary statistic of the measure of the contribution of nature to the economy or to human well-being. And without that kind of measurement, we see what happens. We see that there's going to be probably further degradation of natural capital and the decline of valuable ecosystem services. And I'll provide you with some evidence on that point as we go forward. So I would say that the last, certainly probably since World War II, certainly since 1960, when many of these statistics really become codified and available globally, we have done extremely well as a global community on raising GDP. So this is a chart from the World Bank from 1960 on up to the present. How has global GDP increased? We've done very well. Now, that's not to say that everybody in the world has done very well, but on aggregate, it has increased. But part of the consequence of doing all of the increase in economic activity that we've seen is that we've also changed the global atmosphere. So most of us know very well that we have increased the amount of carbon dioxide in the atmosphere. So this is a very famous chart. It's called the Keeling curve, after Ralph Keeling, an atmospheric scientist who started taking these measures back in the 1950s. And you can see the steady increase in carbon dioxide concentrations in the global atmosphere. Obvious concerns, therefore, with climate change and it doesn't show any signs yet of stopping, right? That curve is still going up linearly, or maybe even more than linearly. The other thing, and something that I spend a fair amount of time thinking about, is more on the biodiversity side. This is a chart from the Intergovernmental Science Policy Platform on Biodiversity and Ecosystem Services, otherwise known as IPBES or IPBES. And I won't say that long mouthful again, it's too many words. So just IPBES here. And in 2019, I was part of a global assessment. What were the status and trends of biodiversity? How were species doing? What were happening to ecosystems? And then what was happening to ecosystem services, the things that nature provides to people. Here's a chart. Again, it's an increase, but not a good increase. This is an increase in rates of extinction for various kinds of taxonomic groups, so mammals and birds and fish and so forth. So, we've got 3 rising charts, but we don't want to have 3 rising charts here, right? We don't want to have rising CO2 levels or rising extinction rates. Okay, so that's, in a nutshell, though, why we're trying to do GEP. We're trying to bring in and make visible the contributions of nature in ways that people understand. So make this parallel to GDP, which people seem to understand readily. What is nature contributing? So GEP is a summary statistic that measures the flow of monetary value from final market and non-market ecosystem goods and services. It parallels GDP, what I've written up here at the top, right? So GDP is the income from goods and services that flow in an economy, right? So it's marketed goods and services. Most of what nature provides doesn't go through a market. So this is the same kind of chart. There's a lot of value that's over there on the right-hand side. So if you think about nature as providing flood protection, or nature as filtering out water pollutants or air pollutants, nature providing wild pollinators, right? Or nature in cities providing greenery that now people in public health have measured the relationship between access to greenery and reductions in anxiety, reductions in depression. So there's a number of ways that nature can contribute to human well-being, and many of them don't go through markets. Some do. So we have agriculture, forestry, tourism. So a farmer raises a crop, they sell it in the market. Some of the value of that crop is due to the fact that they have fertile soil, they have plentiful rainfall, they have pollinators that are pollinating their crops. So some of it is due to nature, but not all of it. They have their own labor, they have tractors, they have improved seeds, right? So part of the value of these kind of things in the middle, agriculture, forestry, fisheries, tourism, would be due to nature. But what GEP is trying to do is capture kind of that whole circle of value. What is nature contributing to the economy? And with GEP, we're doing it in monetary terms. We're doing this in a way parallel to GDP. Okay, there's been some prior work in this area. Most of the work actually started in China. So I've been fortunate through the years to work with colleagues at the Chinese Academy of Sciences. So actually shortly after I started going to China, they started working on GEP, and you can see some of the publications. So the earliest publication that we know of that mentions GEP was in 2013. 2020, the third one down is a paper that I worked on with Professor Ouyang, who you'll see is kind of the constant theme here. And this was the first kind of big international publication of GEP. And I'll talk a little bit about some of the results from that in a few slides. And then a more recent paper, again, trying to explain to a broader audience what GEP is about. I don't read Chinese. I don't know if anybody in the room does, but I will tell you what I know about this, which is from the National Development and Reform Commission in China, which is kind of, I don't know what the equivalent in South Africa is, but in the United States, it would be the Office of Management and Budget. They're the people who really organize the policy process. They're the gatekeepers. They set the process, right? So if you get the National Development and Reform Commission on your side, you're in good shape. Okay, this is their publication. It's in red letters, which is very important in China. So it's a red letter publication that talks about what are the methods for calculating GEP that all provinces, cities, counties are supposed to begin doing. So it's made a lot of progress in China. I wish I could say it's made a lot of progress in the US, but I would be lying if I said that. So I'm not going to say that. Okay, so this is from some earlier work that we had done with Professor Yang and colleagues at the Chinese Academy of Sciences. It laid out a lot of the science that we needed to do. So where are ecosystem services being provided across China? And we did this for a number of services. I put 7 graphs up here, but you can see where is food grown, and where is carbon sequestered across the country, and where is there prevention of soil erosion, and so forth. So this is the kind of information we need to start with this spatially explicit ecological, biological, hydrological information as a base. Then what we did in this paper was we went in 2020, we went further. We built upon that science base and we said, well, what is this worth? What is the value in monetary terms of the provision of these ecosystem services? And this was done as a proof of concept in one province in China. So Qinghai is a province in far western China, up in the Tibetan Plateau. It's actually the headwaters of the Yellow River, the Yangtze River, and the Mekong River. So it's very important ecologically for a number of reasons. We went through and calculated out for a number of what are called material services, so things like agricultural crops or livestock or timber, regulating services, things that ecological processes that they would do to regulate water supply or filter out pollutants from water or air or store carbon, okay? And then there's also, you can barely see it, called non-material services. So many things that are important for people's it could be aesthetics, it could be spiritual or cultural values, but we're not producing a product, we're not changing an ecological process, but it's things that people care about. The only one, unfortunately, we have here is ecotourism. These are harder things to measure. Okay. So with this, we calculated the values of those ecosystem services. We did it in 2000 and 2015, so we could see how is this changing through time. We can show where it's produced, where is the carbon stored, or where is the water coming from, or where are the agricultural crops being produced, and so forth. And then we can also show where people are benefiting from the provision of ecosystem services that are being produced in Qinghai. And some of it is very far downstream in the case of water quality or water supply, or downwind in the case of removing air pollutants or preventing dust storms. And dust storms actually in parts of Western China and Northern China are quite a big issue. Okay, so how did we do this? What data do we need and what methods do we need for measuring gross ecosystem product? So we're in the midst right now of a project where we are calculating or estimating GEP for a large number of services, and I'll talk about that in a moment, for 250 countries and territories around the world, basically all countries and territories as recognized under sort of UN maps. Okay, in one sense, GEP is incredibly simple. I only need 3 things per service. All right, so I need to know, what I'm trying to get to is what's the value of that ecosystem service. I need to know price, P. I need to know quantity, and I need to know this thing lambda. Okay, so I'll come back to lambda in a moment. P's and Q's for economists, this is incredibly straightforward, right? What do we deal with all the time? We're dealing with prices and quantities, right? So how much of a good is being produced? What is the value per unit? I multiply those together and I get a value, right? The value of the whole thing that's being supplied. So that's just like what we would be doing in GDP accounting. There's a little bit of a twist here, which is we have this thing called lambda. And lambda is the share of value that's attributable to nature for a particular service. So if this is the producing agricultural crops, what I want to do is I want to take out the value of the labor of the farmer, right? That's not due to nature, that's the labor of the farmer. Or the value of the contribution of machinery. What I really want is resource rent. I want the contribution of nature to the value. Okay, so let's talk about some of these things. Now, some services are provided, they already go through a market. So we don't have to reinvent the wheel here. We can get price and quantity information from the same system of national accounts that produces GDP. We can get prices and quantities, and so for things like crops or timber or commercial fisheries. But what we have to do is come up with lambda, right? So in GDP, we just take the value of crops. We don't care like what the factor, what factors we're contributing. But here we do care. We care about what's nature contributing. Now there's ways of getting at that. There's a couple of ways. So one is the World Bank, through a publication called Changing Wealth of Nations, has done some of this calculation of trying to figure out what resource rents are, for example, for fisheries or forestry. So we can get some of what we need there. We've also we work closely with colleagues at Purdue University. They have the GTAP model, which is Computable General Equilibrium Model. GTAP is the Global Trade Analysis Project. And as part of that computable general equilibrium model, they also compute out shares of factor input. So they have a labor share to a machinery share. So we can get at this lambda through that as well. Okay. That's fine for market ecosystem services, but the whole point of this really was there's a whole lot of ecosystem services that don't go through market. So how are we going to get to this non-market value that don't have market prices? Okay, so there's several approaches, and I'll talk through them quickly. Now, the good news is that most of the time for these non-market ecosystem services, the lambda is 1. So I don't have to come up with that, but I do have to come up with the P's and the Q's. Okay, so calculating these prices and quantities. In this natural capital project, which you mentioned, so this natural capital project, we are now 20 years old, and we have one of the main things that we have been trying to do is to be able for anybody in the world to evaluate ecosystem services and how ecosystem services change if you change land use or if the climate changes, land management changes. So we've put together a series of modules for ecosystem services packaged as INVEST, which stands for Integrated Valuation of Ecosystem Services and Trade-offs. We can use this INVEST models and some others to calculate the quantities, biophysical quantities. How much carbon is being stored? How much air quality is being improved through filtration from vegetation, and so forth. And then there are ways that we can use to come up, or approaches we can use to come up with the prices for these ecosystem services. So if I'm talking about pollination services, again, I have to have a way of coming up with how much have the wild pollinators improve the quantity or the quality of the crops. Okay, that's kind of the hard part. Once I've got that, though, the price information, well, crops are marketed, right? So I can use the value of the market value of the crops. Air pollution is a little more difficult. We again have to do the biophysical modeling to talk about how much have we reduced particulate matter that's air pollutant that causes premature mortality. So we need to calculate out how many people have we, how many deaths have we prevented by giving people better air quality. Once we're there, we can apply what's called the value of statistical life. So empirical evidence on like how much are people willing to pay in order to reduce their odds of premature mortality. Those of you who don't know this literature, at first, I have to admit, I was the same way. At first, you hear this and you go, oh my God, you people are morbid. Um, and I still feel that a little bit. But the point is, we do make decisions that have risks. People take risky jobs, they undertake risky behaviors. And so, can we uncover, as we do many times as economists, how much is that? What is the trade-off people are willing to make between those risks and the cost of an activity? So how much do you have to get paid more for working a risky job, for example? Okay, carbon storage. We can get, there are calculations of what are called the social cost of carbon, which is how much is it worth to society for reducing a ton of carbon, removing it from the atmosphere, and therefore having less severe climate change going forward. We don't want the whole social cost of carbon. We want what's the value of storing that carbon for 1 year, because we're interested in an income. We're interested in a flow value over 1 year. So we'll look at the annual rental price of carbon. Okay. Sometimes we also, especially I talked about this mental health issue before, there we don't estimate prices and quantities kind of separately. What we do is we use literature and we get an assessment about how much does nature reduce, say, depression or anxiety. And then we will use, again, literature values for what's it worth to society or worth to the individual for reduced depression or anxiety. Or if it's a physical health measure and reduced premature mortality, we're back to the value of statistical life. I'll just walk through one just to give you a sense, like what does this really entail, doing this kind of exercise? And we're doing this, again, service by service. So each of the services that we have, we're calculating a value. We need prices, quantities, and lambdas for each service. So air filtration is an interesting one because you have to go through a number of steps in order to do this. So really what we're doing is it's a pathway from what's nature doing, how's that changing air quality, either emissions or deposition, how's that changing exposure, and then how does that contribute to health outcomes, and finally, what's the value of those health outcomes? So first thing we're going to do is we'll use models that talk about, or models that are built on empirical measures that look at what is land use, how does that relate to emissions that lead to formation of particulate matter, PM 2.5, which is the small particles that get into your lungs, and those are the really dangerous ones that lead to premature mortality. So there's a number of different pathways that this can happen. It can happen from trees producing volatile organic compounds, or it can be from soil releasing nitrogen oxides, or it can just be windblown dust or burning of biomass. Okay, but nature also filters out some of these pollutants. So there's deposition of pollution on vegetation. So if you have a lot of trees or other vegetation between you and a pollution source, some of that pollution will be filtered out before it gets to you. So we're looking at that filtration benefit. And then we use what's called, we use an air pollution model called the global INMAP model that takes account of where emissions are occurring, where's the wind distribution taking it, what's the atmospheric chemistry. And then we get to exposures of people, and we use a dose-response relationship. So if I breathe in less harmful air, how does that translate to improved health? So what would the kind of exposures be with and without that filtration from nature? We can use a global exposure mortality model to translate that into health benefits, and then finally translate those health benefits via the value of statistical life into a dollar value. Okay, so you see we're walking through a number of different steps. We have to have expertise from people who know about air quality, to people who know about health, to people who know about economics and putting things into monetary terms. final step here. If we're going to aggregate this into a GEP value, a kind of a sum or aggregate value, we have to be careful not to double count. So I can't count both the value of pollinators, which are an input into crops, and then count the crops too, right? I can count one or the other, but not both. Okay, so there's ways of doing this, but we have to be careful of that. But we also don't want to undercount, all right? We're trying to get in like all of the important ecosystem services. So the philosophy of our project so far is, I've told the team, if you think you can't count it, then it will come in as a 0. Is what you can do with the methods and the data that you have now, is it better than assigning a value of 0? Okay, so sometimes it's not. Sometimes the data and the methods are so poor that we really can't put it in. But oftentimes we can get at least a rough estimate. And so we're trying to get in rough estimates at least for every important ecosystem service. So here's our list actually of what we've included in our ecosystem services. I guess I should explain this note of biotic versus abiotic. So biotic means it's living nature. Abiotic is non-living nature, water, rocks, not the vegetation. Some people restrict ecosystem services to just being biotic nature, living nature. Others take a broader view of anything in nature, whether it's living or not, contributes. So if we dig up rocks that are rare earths and that has value, it wasn't created by people, it's a value that's coming from nature. So we actually are going to report both a biotic GEP, what some people would call sort of a classic ecosystem services aggregation, and then a broader one that some people might call an environmental valuation, which includes both biotic and abiotic. But if you scan this chart, we have incorporated a large number of both regulating services and material services. The non-material services, well, good news is we've tripled what we did in 2020, but the bad news is we still only have 3. Okay, so we have recreation and tourism, we have these physical health benefits from nature exposure, and mental health benefits from nature exposure. We do, as I said, have to worry a lot about double counting. So the ones in red are the places where when we aggregate up, we can't count both the value, for example, the pollinators and the crops. There's work ongoing at the UN Statistics Division on something called SEA, System of Environmental Economic Accounting. So we have crosswalked all of our services with the categories that they have. And these are the list of ecosystem services that are in SEA that we don't have yet in GEP accounting. So the good news is there's a lot more in than are out. Hopefully as time goes on, data will improve, other expertise will come on board, and we can onboard some of these other ones as well. Okay. Right now, for this current project, we are evaluating GEP for the year 2019. Why 2019? Well, we have good data availability in 2019, and it was pre-COVID, so we don't have the kind of COVID craziness to deal with. We convert everything into 2019 international dollars using purchasing power parity to get things into dollars. So adjusted the exchange rates to purchasing power parity, and we, if we had some number that was say 2015, we inflate that, or if we had a number later, we deflate that back to 2019. So using kind of standard approaches that people use for this. Okay, so what do we got so far? These are partial results. We are in the midst of this project, and since we're in the midst of this project, I'd love to hear any inputs that you all have. But so far, I'm just going to talk about 3 services that I have greater confidence in right now about the estimates. We're still in the midst of sort of sanity checking, I'll just call it, of the results and having experts review these. And we hope that by middle or end of the summer, we'll have a full set of results. But here are results for these three, and what I've done is not report them for all 250, but countries that are in the top 10 value for any of these three services. So in the first one, you can see the annual rental value of carbon. So these are substantial numbers. That's $5.3 trillion annually for the value of rental value of stored carbon. And this is in terrestrial and coastal ecosystems. We also have marine carbon, and that's not in this figure. Okay. Second column is what's the value of air filtration, and that's 17.8 billion. So obviously orders of magnitude less than the carbon value, but still a significant value. If we were talking about the value of air quality overall, it would be a bigger number, because what we're doing is just talking about what's being contributed by filtering out pollutants by nature. Okay, so if you shut down all the coal power plants around the world, you would see a much bigger increase in health, and the numbers would be bigger. But we're just looking at that portion that's due to nature. And then a more conventional one, the hydropower production. Okay. So these values are significant, but as you can see, some are more significant than others, like the carbon values. But in some particular countries, things are really significant. So if you look at the Democratic Republic of Congo, did not have a particularly large GDP, so classically measured value of economic activity in DRC is 37 billion in 2019. If you look at the annual rental value of carbon stored in the forests and other ecosystems in DRC, it's 263 billion. Right? So some places this would be obviously if this were an industry, this would be a dominant industry in the DRC. Okay, so where are we on this project? Well, this is a first estimate of GEP that's broadly done across countries, across multiple ecosystem services. We think it provides tangible evidence of the value of nature in economic terms. We're trying to do this in a very transparent and rigorous way. We are welcoming if people say, well, we don't like how you calculate, let's say, air filtration, or we don't like how you calculate. It's like, great. You got better data, you got better methods, good, let's put them in. We are aiming to develop a standardized set of methods and data that can be used anywhere for this GEP accounting. And frankly, part of this too is overcoming the skepticism of people who say, oh, this can't be done. It's like, look, we're not super people. We're just normal people. We're hardworking, yes, but you can do this. There is enough data, and there are methods out there that we can put this stuff together and calculate a GEP. I'll talk about it at one of my slides later on. It's the comparison to GDP. Well, I'll just mention it now because given time, I'm not sure I'm going to get to all my slides. So anyway, think back in the 1930s, we didn't have GDP. We didn't have a system of national accounts. You know, the pioneers back then were trying to figure out, like, how do we measure the value of all the economy? How can that be done? And there were many naysayers that say we can measure the tons of steel and we can measure, the number of automobiles, but how do you compare steel and automobiles? How do you come up with one number? And we hear this a lot as well. You can't put a price tag on nature. And it's like, we're not putting a price tag on nature. We're saying how much value is being created by nature, right? So, we're trying to, again, overcome some of the skepticism, but clearly this is the first step. It's not the final or last word of GEP. I mean, GDP and the system of national accounts are continually being refined. And this will be a process of continual refinement as well. We hope to stimulate the research community to highlight some of the knowledge gaps, highlight some of the data gaps, and kind of get on with it. We need to get this stuff done and out there, and nature being visible rather than being invisible. I'd mentioned SEIA previously, the System of Environmental Economic Accounting. SIA does both biophysical accounting up in the light blue, and they do monetary, or they have a framework for doing monetary values, which are the darker blue down below. And SIA also lays out stock accounts, so kind of a wealth accounting, as well as a flow account or an income accounting. So on the right-hand side, you have income like GEP and GDP. On the left-hand side, you would have the value of wealth. And depending on how much time I have, we'll talk about inclusive wealth. How am I doing? Okay, we'll talk a little bit about inclusive wealth then. Okay. Just before I get to inclusive wealth, though, I do want to say, some people say, well, then how are these things being used? How would you use GEP? When I started this project, I'm more comfortable, frankly, from the microeconomic side and thinking about benefit cost analysis. And you can certainly use a lot of the information that we're doing to evaluate projects or evaluate policies in particular places. But GEP has been used in a number of ways which I hadn't expected at the beginning. So in China, as I said, where this is better developed, they are using this to talk about ecological connections among regions and therefore as payments between regions for provision of ecosystem services. Serves as a metric, performance metric for government officials. So it used to be in China, if you grew your GDP, you were good. Now you have to grow GDP and GEP in order to be viewed as doing a good job. The cities of Beijing and Shenzhen, for those of you who don't, everybody knows Beijing, right? But Shenzhen is a city also of about 20 million people. It's sort of the center of electric vehicles and computer software. It's a very sophisticated place. Both Beijing and Shenzhen are using GEP in their planning and evaluation. They're also using it in Beijing they have all of the districts within Beijing getting evaluated for how has that district done in terms of have they increased their provision of GEP or has that declined? Have they met their target for GEP? And if they have, they get extra revenue, extra resources. If they haven't, they face a penalty. So it's really like establishing, in a way, a market for local provision of GEP because there's rewards and penalties for making or missing your targets. And finally, these two mountain banks. These provide low-interest loans to companies that are engaged in activities like promoting ecotourism or restoration of ecosystems. So if you're doing an activity and it has ecosystem services, you get a better loan rate, okay, or better access to investment capital. Okay, you tell me when I should stop. 3 minutes. We'll do inclusive wealth quickly or talk about it. So first of all, why? Okay, so GEP is important, but it's not everything, right? Just as GDP isn't everything, but one of the particular things that we need to think about beyond GDP and GEP, these are income measures, but they don't say anything about future well-being, right? So if I know current GEP or current GDP, that doesn't tell me how the next generation is going to do. So if we're interested in sustainability and sustainable development, we need to talk about both current and future well-being and thinking about wealth or stock assets or what are we leaving to the next generation? What are the value of the assets which the next generation is going to have? That's much more relevant for thinking about sustainable development, okay? Because we know, for example, that you could inflate GDP or GEP right now by pulling down your stocks. Like I could cut down all the trees in the forest and I'd get a great timber value now, but I would be impoverishing the generations to come. Right, so inclusive wealth is a notion looking at the aggregate value of all capital assets. So not only natural capital, which we're concerned with, but also human capital, manufactured capital, social capital, and putting this into a common monetary metric. So the question is the value of all of the capital assets increasing or decreasing? Okay, I'm going to skip over a bunch of slides here. A lot of prior work. We'll give you access to these slides, so if people are interested, you can find them. Too late in the day to do math, so we'll skip over that too. But what I really want to talk to you about is why we're, what's really valuable about inclusive wealth. Well, you can show, like some of those papers that I just skipped over, show you that non-declining inclusive wealth is really equivalent to non-declining human well-being. Okay, intuition for this is straightforward. If I'm giving you a greater set of assets, more valuable assets, and the value of the assets is what it's contributing to your well-being. If I give you a greater set of assets, you can be better off. Okay, if I impoverish you and don't give you as good set of assets, you're not going to be as well off, no matter how much you try. Okay, so the notion here is if we could measure inclusive wealth, and we could talk about whether it was increasing or decreasing, we have a really good measure of sustainable development. Okay. The problem with inclusive wealth is it's really difficult to measure. I mean, what are the values of all of these natural capitals and human capital and social capital? We have a hard enough time as economists measuring manufactured, physical capital. What's the value of buildings and things like that? So this is a hard thing. Again, too late in the day to do math, so we will skip over that. What I'm skipping over now is actually this is a really nice paper by Ken Arrow, a Nobel Prize winner, and several co-authors, trying to calculate out inclusive wealth for a number of different countries. So for the United States, China, Brazil, India, and Venezuela. They show the point that if you include some type of measure of inclusive wealth, that per capita GDP growth kind of is too high. It sort of gives you an inflated view of the future. You really should have taken into account the depreciation of your capital stock. This exercise is informative, but there's huge data gaps, and many elements of capital are not included in that. So there's kind of a stark contrast between the theory and the limited ability to measure capital stocks and that. Very nice book that was produced. There's two other Nobel laureates, Joseph Stiglitz and Amartya Sen, talked about mismeasuring our lives, why GDP doesn't add up. This was commissioned by the French government. They talked a lot about how would we try to get to a measure of sustainability, kind of like what we're talking about in inclusive wealth. They said, right now, this seems like an overly ambitious goal. It's really hard to see how we're going to get the values of these things and to be able to aggregate them up into a common metric. So where they ended up is something called a dashboard analogy. So if you think about like your car, like we don't have just one measure of performance for the car. We have things like, am I running out of gas? Where's my engine running too hot? How fast am I going? Those are different things. And so what they talked about with this, I'll call it semi-inclusive wealth, is sure, we'll try to measure and combine some things, but we'll also have different metrics. But I actually think with this gross ecosystem product, we can make some progress, at least on the natural capital side. So if you think in theory, what is the value of unit of capital? Well, the value of unit of capital should be equal to the present value of the flow of services that it creates. Well, what's GEP doing? That's getting you the value of the services that are being created. So if we combine our approaches to measuring GEP with some scenarios about future conditions, we can actually get to a trajectory of GEP through time, which could help us actually estimate what the values of natural capital are. It's a tall order. I mean, I don't want to minimize and say this is too easy, but it does give us a path forward so that we actually could fulfill what the system of environmental economic accounts is attempting to do and get to both measures of the value of assets and the flow value of income. Okay. So let me end by just kind of reiterating a couple of things or saying, there are clearly things that this is early stage that we need to do better, but we're trying to get complete coverage of important services, standardize a rigorous methodology, ground truth, make sure that our estimates are reliable. This next bullet point is a tall order, actually, getting buy-in from national statistical offices. They do things a certain way. We're asking them to do something different. We have to convince them that this is really important and that they need to kind of broaden out and allow these system of environmental and economic accounts not to be satellite accounts, but to be brought within the kinds of things that they deal with. Creating a time series and dealing with uncertainty. We deal with biophysical uncertainty and there's price uncertainty here. So how do we incorporate a realistic notion of uncertainty into this? But I'll just leave you with this one last thought, which is in the 1930s, when we were developing GDP and the system of national accounts, I mean, these didn't come out of nowhere. I mean, people had thought about ideas of coming up with economic accounts before. But the real push for it came from the fact that we were in the midst of a Great Depression and we needed better measures of economic performance. So that pushed really the start of GDP and national system of national accounts. Well, I think right now you could claim that we're in the midst of a great degradation of natural capital, and that in the same way that the Great Depression pushed us towards a system of national accounts, this great degradation, yeah, they agree, okay, should lead us to better metrics of ecosystem services and natural capital to help guide sustainable development. So let me stop there and thank you all very much for your attention.
Thank you very much. That was very interesting, and I liked your very African photos. I have two questions for you. One is I'm quite confused about the DR Congo stats because they're one of the biggest tropical forests, and then the air filtration is very low in comparison to the others. Sorry, I'm Jill Hamilton, and I work with civil society in South Africa. And then my second question is I'm curious about your perspective on South Africa's natural capital accounting that we've got in our stats that's been collected by our stats office. Yeah. I've tried to engage with them, but I haven't done very well.
Okay.
Thanks.
Great. Yeah, great questions. So I'll start with the DRC one. Clearly the forests there being so huge and in a way, I mean, they're a global resource, which is what this shows. So those numbers make a lot of sense. The filtration numbers are because there's not a lot of pollution in the DRC. And therefore, the air starts pretty clean. You filter it, it's still pretty clean. And so there's not a lot of population centers that are getting huge benefits on the air filtration side. Now, if you put a whole bunch of coal plants up in the DRC, then you get a lot better, but the air is good, which is why the value of the filtration is low. So you do get these. I mean, this is sort of a paradox that we get within GEP. Sometimes, it's not the pristine places in the world that necessarily have high GEP. One, because here for the air pollution example, but the second is there may not be a whole lot of people around who get the benefit. So if we filter the water upstream from Kinshasa or another large city, that's going to give us a lot of value. If it's off in a very remote area where there's not many people, we don't get high value. And then South Africa. So I spent yesterday at the central bank, and so they were interested enough to have a presentation on natural capital, and so the South African Central Bank is part of what's called NGFS, the Network for Greening the Financial Systems. So it's just a collection of central banks which are all interested in thinking about how do we make sure that we're taking into account climate risk and now increasingly nature risk. So Treasury was there as well. So this is not the usual suspects of just the environment ministries, but these others. I will say, part of the reason for having been into South Africa before is that There's a really good community here on the biophysical side. So I started coming here working with ecologists. But increasingly there are people who are doing this work, taking this in. So South Africa actually has a better set of work in progress than, I mean, there's places in Europe that are really good. So the Netherlands, the UK, China, as I've said here, but I would put South Africa on the list of really forward thinking and countries that have done a lot. The water accounts, for example, are really good. Yeah.
Thank you. This is a very interesting deliberation.
Yeah, it's on.
So I just want to ask you, I just want to take you up on the question of the concept of value specifically.
Yeah.
I'm not quite sure. I mean, if you look at value in terms of GDP, right, and there are different schools of thought. Okay, so you'll have Marx talking about the labor theory of value, and then in monetarist perspectives, they will have a different sort of idea. Now, I don't know which sort of school of thought you use to measure value, and this is the reason why I'm asking this question.
Yeah.
You say that some people say to you, well, you can't exactly put price on nature, which is fair.
Yeah. And
then you respond by saying, well, you're just trying to extract value. Right? This is what your ultimate goal is, just to extract value.
To show value.
Yeah.
To show the value.
Right.
Yes.
To show the value. Now,
yes.
I'm not quite sure how useful that is, and I'd like clarity on that. If that value does not then lead to an expression, at least in monetary terms, of that value. So, for example, if you give me the value of gold, I can only express that in terms of price, right? Which leads me to then put a price on gold.
Right.
So that's why we speak of gold prices,
right,
because we know what the value of gold is.
Yeah.
So with nature, I'm not sure how you go about doing that, because how do you then measure value for air, for example? I don't know if my question makes sense.
So, yeah, no, this is a great question. So this is basically coming out very much in the tradition of microeconomics, welfare theory. So thinking about the value of consumer and producer surplus. So really what we're trying to get to is a measure of the change in welfare. We oftentimes as economists will say, well, let's try to express this in a common metric. Our typical common metric is monetary value. So what is it worth to you in terms of the price or the value of the market value of the goods? So, you said, well, what's gold worth? I mean, you can look it up in the newspaper. That's the market value, right? Doesn't tell you necessarily what the welfare value of it is, but economists interpret the market prices as the marginal willingness to pay, the marginal contribution to welfare. We're using the same thing. So on the non-market side, we would be saying, so let's talk about that air example, right? We would be saying it's certainly valuable to people if they have better health, right? People would be willing to pay for better health. How do we uncover that willingness to pay or that value of improved health through the value or through the change in air quality and therefore reduction in disease that they have? So we're using exactly the same methodology in the market valuations that GDP uses. We're doing this, but we're extending it. So we're talking about things which don't go through markets, but we're using that same kind of welfare economics calculation in order to do it. Now, it works well for some things. Like it's much closer. Well, I mean, even health is kind of understandable in that way, but it works very well for things like, oh, I'm reducing probabilities of catastrophic flood, and therefore there's lower value of property damage. What's that worth? Well, we can talk about the change in the property values, right, with the reduction in, or the reduction in damage associated with flooding. Other things, especially in the, when we get to some of these non-material services, so where you grew up, like the nature that was around you where you grew up, most people are attached to that. What's that worth? That's a really hard thing to try to put into monetary terms. I know the value isn't zero, right? But I don't know really what it is, right? And so there are certain things which are kind of easier to put into this welfare calculation sense, and others which are harder to measure. But
thank you for that. One of the things that I want to ask of you is just to talk through what you think might be the sort of political implications of this, because I mean, we had this story of the DRC. I mean, if you think what wealthy countries might owe countries that have less sort of depleted their natural capital in the system, is kind of the question that comes out of these international dialogues about climate change. And I'm sure it's of interest to people. So I'd just like your thoughts about where this goes in that sense.
I guess this is kind of similar, and I was still trying to figure out how to articulate it. I'm really happy that this work is happening. It's great. I think this is all very valuable contributions, but I do worry about the bigger picture, kind of like the more we quantify, we perpetuate this idea that the best decisions are made when you have enough information, if you can quantify stuff enough. And yet the decisions we really need to make right now, I mean, you know, we can calculate a social cost of carbon, but there's a politically acceptable cost of carbon which prevails. And I just wonder if you have thought about how to deal with this danger of perpetuating the idea that if you just do enough quantitative analysis, you're going to reach decisions that are in the public benefit, when that doesn't have a good track record.
I'm Lerato Pasha. I'm a practitioner and a student. Work a lot with civil society, so this is interesting. My interest in this is how we use this methodology to translate into measurable ways to protect the environment, one, through sustainable development, but practically through litigation. We know we have a huge framework for environmental law, but it is always preventative or responsive. We never use this type of methodology to say, well, yeah, you want to build a mine here and it's going to be worth 2 billion, but don't, because the environment in this area is worth 50 billion. So how do we do that practically here in South Africa? Thank you.
Well, there's a lot of synergy between these three questions. So this is I'll try to package it. Yes. Let me take the last question first. And sorry, when I'm at the mic, I can't see you, but I'll forgive me for that. So we actually have a case in where I'm from, Minnesota in the U.S., of a mine opening up right outside, or potentially opening up right outside of what's called the Boundary Waters Canoe Area, which is it's a wilderness area, and it's beloved for recreational value and clean water. If you have a copper nickel mine right at the edge of this area where the water from that mine would flow into the boundary waters, you now have a conflict. And so, you know, on one hand, you've got many of the local labor groups and the mining interests saying, you know, it's worth $2 billion to us to open it up. Right now, the people on the boundary water side don't have a number. They just have a feeling that this is important. So one way that you could then do this, in fact, we were asked in this case to come up with, well, what is the value of the tourism that is dependent on having the clean water? What's the value to the vacation, the people who come up there for the clean water and so forth? What are the other ecosystem service values? So in principle, one could add up those values, and in the case of the boundary waters, since it is a national treasure, they are arguably quite large and probably larger than the values of the mine. Okay, but then let's transition to the question that you asked, which is, can you really do this? You know, in a way, this was like, let's cost-benefit analysis, right? Oh, we're going to weigh up the cost of the mine and the benefits of the mine, and we'll see it. And inherently in these things, there are things that cannot be quantified. They're sort of beyond it. So there was a really good paper back, it's now 30 years old, but it's still really good. I like to think of things that are older as still having value. it basically was talking about how should you think about information from a benefit cost analysis. And this was put together because there was a huge controversy in the United States about benefit cost analysis and its use in public policy. And what they said on it was, this is information, and it's useful information. It's important for places like the Boundary Waters to put onto the sheet, here are the important values of preservation and not just what are the values from the mine. But it's never going to be the complete story. So you don't use the benefit cost as your decision rule. You use it as information to help you inform the decision. So ultimately, at the end of the day, it is going to be a political process on this, and somebody's going to make decisions. I would argue I want them to have this environmental information rather than not. But ultimately, it's going to be a political choice. As somebody coming from the United States right now and talking about rationality and government or irrationality and government, I hear you. And it's very easy to get depressed about the state of the world and how we use or misuse information. I'm going to be from a really diverse part of the country, right? We had our own form of occupation over the last couple of months in Minnesota. So yes. But these are really good questions. I don't have the political economy full set of answers, but I am sympathetic. I mean, I do worry about, is this going to get used or misused? Frankly, in this one, for the carbon values in DRC, I would say, let's get this information on the table, because this boosts the bargaining power of a DRC relative to Europe or the United States or Japan, and say, we have an asset here that's worth a lot to the global community. We don't have a lot of income ourselves. The global community should be helping out and thinking about how to maintain these values. So in this particular case, I think we're in good grounds. In China, these poor province, Shanghai is a very poor province relative to downstream, like relative to Shanghai or other places. So what we were arguing there was, if you paid for these provision of ecosystem services, you'd be taking money mostly from richer communities and putting it into poorer rural communities. But that's not to say that that's always going to be true. So I think it's always good to ask your question. And in some cases, we may, it may be an uncomfortable answer. So far, the answers, I think, have been positive, but it's no guarantee.
Thank you. I hate to play the spoil sport, but we are already about 15 minutes past our scheduled stop time. But there will be, I hope, opportunity for those questions that could not be posed over the refreshments. Please do take up that opportunity. But at this point, I really want to thank Stephen for the time he made for us. Like he said, he had a busy day yesterday at the Reserve Bank, but he still made time, and that's deeply appreciated. I have to also extend my formal gratitude to Pro Vice Chancellor, Professor Imraan Valodia, for giving the School of Economics and Finance this opportunity to host this great presentation. Fascinating ideas that has given us a lot of food for thought, but like Stephen would be the first to admit, the questions are still out there, and we have to continue probing these to find answers. No perfect solutions exist at this point. But that's food for thought, and I hope for further discussions over refreshments. Before I conclude, I want to thank the team from SCIS, particularly Rahul Gandhi and his team, and also Mamosa and Hloni here for the logistical support. Thank you all.
Thanks.